Hey everyone, welcome back to the channel. Today we are going to solve a very interesting Leetcode problem. Leetcode problem is 2221 and it's a find the triangular sum of an array. Okay, so this is a beautiful little problem that looks simple, but it's it hides some really nice connections with Pascal's triangle, modular algorithms, and combinatorics, we can say that. Okay, so a couple of things we have here to learn. So by the end of this video, right, you will understand the problem clearly, and you will see how to go by the step by step to understand how to approach this type of problem. And we'll do the dry run, and we'll try to learn multiple ways to solve this problem, from brute force to the clever math shortcuts, we can say that. So let's dive in here. I will suggest please pause this video and go through the statement that we have given here. Okay, and then we'll discuss. Okay, so what the question is saying, that you are given zero index integer array that is called nums. Okay, let me zoom a little bit. Okay, so it is saying you are given zero indexed integer array nums, where nums at I is a digit between 0 and 9. That is called inclusive, means we have to take 0 and 9 too. Okay, so nums at I means each digit or elements of the array is a digit between 0 to 9, we can say that. Okay, the triangular sum of nums is the value of only elements present in nums, okay, after the following process terminates. Right, means the triangular sum of the given array is the value of only elements present in the nums. What are the things we have to process? Right, it is saying let nums comprise of n elements if n equal to 1, end the process. Otherwise, create a zero index integer array new nums of length n minus 1. Means you have to reduce the length if it is not n equal to 1. If n equal to 1, it means you have to process and that this is completed. In otherwise cases, you have to create a new array with n minus 1 size. For each index I, it could be greater than 0 and less than n. Okay, so I can be greater than equal to 0 and less than equal to n minus 1. Assign the value of new array element, right, as we have to take the sum of consecutive elements and take the modulo of 10. So modulo value, you take the modulo, right, it will give the new value, right. That value should be assigned to the newly created array as a elements. Okay, then it is saying replace the array nums with new nums. So the new nums value should be replaced directly to the nums. So the new nums, previous nums value should be removed, and the new value will be get updated on the nums. Repeat the entire process starting from step 1 and return the triangular sum of nums. So this process we have to repeat, and we will each time we will find the new nums, and we will remove the previous value, means you will replace this. You will do this entire process until you will not find n equal to 1, and you will return the triangular sum of nums. So if you come here, if you see this example, we have 1, 2, 3, 4, 5. Let's understand. We have 1 and 2. If we'll do the sum and if you'll take the mod, right, you will get 3. With respect to 2 and 3, you will get 5. With 5 and 4, you will get 7. 5 and 4 and 5, you will get 9. Again, with the 3 and 5, you will get 8. 5 and 7, you will get 12, but you have to take the mod 10, so you will get 2. Similarly, 7 and 9, you will take the 16, but you have to take the mod of 10, you will get 6. Similarly, we have 8 and 2, you will get 10, so 10 mod 10 is 0. Then you will get 2 and 6 is 8, you will get 8. And 0 and 8, you will get 8. You know the mod, if it is taking the mod of 10, means if any value gives more than 10, you will take the its first digit and rest of the digit will be removed, like that we can say. Okay, I hope you understand this. This is easy thing. So nums, it is saying that we have this one and we will return 8. Why will it return 8? The question itself saying that, as you can see this picture, which picture explain everything, right? This is easy. Okay. Similarly, we have given a single element. If there is only one element, when n equal to 1, you will not do anything, it will end, right? And so you will return 5. This is what we have given. Constraint length should be greater than equal to 1 and it should be less than equal to 1000. Similarly, num set I will be an element between 0 to 9, inclusive 0 and 9. So let's try to understand. Okay, so let's try to understand an example. Okay, very first, let's suppose we have given an array is like this. Okay, let's call 1, 2, 3, 4 and 5. Only 5 element we will take. Okay, let's suppose we have given the array nums and these are the digits we have given 1, 2, 3, 4 and 5. So at each step we will replace the array with pairwise sum. Let's call the mod will take 10, right, each time if we'll do the sum. So very first, let's suppose this is the value at index 0, 1, 2, 3 and 4, and this is called nothing but I. So if this is I, this will become what? I plus 1. If this is I, this will become I plus 1. This is called consecutive, right? What it is saying? It is saying if this is nums, right, means nums at I plus nums at I plus 1, right? You have to take this and you have to take the mod of 10. For example, if we have 1 and 2, right, we will write 1 plus 2 and you have to take the mod 10. Here 3 mod 10, you will get 3. Okay. Similarly, for other cases, let's understand. We have is 1, 2, 3, 4, 5. So we have already completed these two. Now we'll complete this and this. When this is I, this will become I plus 1. Okay. So we have to take 2 plus 3 mod 10 is nothing but 5. Correct. Similarly, it will take these 3 and 7. 4 is nothing but 7. So 3 plus 4, it become what? 7. Similarly, this 4 and this 5 become 9. 4 plus 9 mod 10 become 9, right? Now the newly created array is saying the new nums. So the previously it was what? 3. We'll say 3. Now it is 5, 7, 9. So the new array become is 3, 4, 7, 9. So now we have to update. So previously that you have created these nums, so this nums is not now this. We have to replace this value with the new array, right? This is the new array. So what you will say, okay, now this is nums equal to 3, 4, 5, 7. This is the new array created, 3, 4, 5, 7. So we'll say, okay, if nums is equal to 3, 4, 5, 7, correct? Which is n is not equal to 1. If n is not equal to 1, means we will not do AND, right? If we will not do AND, means we have to process again. Again, if this is I, this will become I plus 1. So we'll say 3 plus 4, and we will process again with the mod 10, we'll get 7. Then 4 and 5, if this is I, this will become I plus 1. So 4 plus 5 is 9. So we'll take okay 9. Then this 5 and this 7, 5 plus 7 is how many? 12, right? 12. So 12, if this is 12 mod 10, it gives you 2, right? Okay, so the newly created array again become what? New nums is what? It will become 7, 9 and 2. Still it is not equal to 1. Its size is 3, right? So we'll say, okay, now it will be updated with the nums. So if it is nums, size is this, we'll process again. If this is I, it will become I plus 1. So we become 7 plus 9. We'll take the mod 10. 7 plus 9 is 16, right? 16 mod 10 is 6. Again, we'll say 9 plus 2 we will take. We'll take the mod 10. Here, 9 plus 2 is nothing but 11. We'll take the mod 10. We'll get 1. Now the newly created array become 6 and 1. So we'll say, okay. Directly we'll write the here. It was what? 6 and 1. 6 and 1. So this is the new array. Still n is not equal to 1. So what we will do? We'll do the sum. 6 plus 1 mod 10 is 7. So we'll say in the last we'll get is 7, and this will be our answer. Okay, maybe there will be mistakes, so don't worry. If you can find it, okay. So this will come this is the way we will find the answer, right? And we'll return the answer. I hope you understands this problem, and this problem approach when you get the what you call the digit, right? The final single digit you will get. This final digit itself is called triangular sum. This is called triangular sum, because if you see, right, previously it was 1 2 3 4 5. So we can say it was 1 2 3 4 5. Then after that the new array we have created is 3 5 7 9, means 3 7 3 5 7 9. And then we have created is after 3 5 7 9 we have created what? 7 9 okay, I did mistake here, that is why it is looking okay. We should take 3 4 5 7. We should take 3 5. We have taken extra 4 here, so this is wrong, right? I have calculated wrong. Okay, it's fine. Similarly, we'll take 3 something will take, right? And we'll we can directly here write, don't worry, let's write here. Let's take, we have 1 2 3 4 and 5. So 1 2 will become what? 1 and 2 will become what? 3. 2 and 3 will become what? Is 5. 3 and 4 will become what? 7. And 4 and 5 become what? 9, right? and we can, if more than 10 10 and more than 10 comes, it's will be the one of first digit we will take, right? Similarly, we have what 3 and 5 we will get is 8. 5 and 7 will get what? 5 and 7 will come 12. So we'll take 2. And 7 and 9 is 16. Then this time we will take only 6. 8 and 2 is 10. So we'll take 0. 2 and 6 we will take is how many? 8. So we'll take 8. Now we'll do the sum again. 0 and 8. This time we'll get 8. So if you see, this is coming as a triangle, right? This comes as a triangle. So in the last, if you see, this value is nothing but called triangular sum. Triangular sum. So whenever the value becoming great, sum is coming greater than equal to 10, and we are taking the mod, right? If you take the mod 10, right, it will give this digit will be deleted, only this digit will come. I hope you understand the mod, right? Let's suppose 10 will get 0, 11 get 1, 12 give you is 2, like that we will get, okay? And that is why we have calculated like this. I hope you understands why we are doing this. So we'll keep compressing until only one numbers comes or left, right? Means when it is saying if num size become 1, means n is equal to 1, in that case we have to stop this process, right? Otherwise we'll keep compressing until only one num is left, okay? So actually if you observe this, right, this is nothing but give me 1 second. Okay, so this is nothing but, we call this row 0, this is row 1, this is row 2, and this is row 3, and this is row 4. Can we say that? So when we reach to row 4, we get the 8, and this will be our triangular sum. It means what? We goes by row, right? So each row we are going there, and for each element we are taking, this is I and this is I plus 1, and we are picking that and we are making the sum, and then we are doing the mod, so the resultant will get added in the newly created array, right? And we are processing each time. We only take the mod 10, that we have to think about it, right? So if you see, we use an arrow we can say, or sliding window, right? So sliding window of 2 elements, we can say that. So if we are picking the very first 2 elements, I and I plus 1, right, then we will pick this one. Again we will slide the window and we'll say, okay, the next window should be what? This 2 and 3, right? So this will become I and this will become I plus 1. Similarly, if we will move ahead, we'll say, okay, now we'll get these 2 elements 3 and 4. So this time it is I, and this will become I plus 1, right? And in the last we'll say, okay, take this 4 5. So like we are taking the I and I plus 1, we are moving our windows. Similarly for these cases also, we are doing operating on the same way. We are sliding the window, right, and we are finding nums and nums at I and nums plus nums I plus 1, and we are creating the new I, right? What we are doing, we are doing let me write here, we are doing what? We are taking two things, nums at I plus nums at I plus 1, and then we creating a new I, you can say that, right? And this new I is nothing but as a temporary a new array, right? So this way we are going until you are not reaching the size equal to 1. If coming equal to 1, we will process this end, right? So you will say, okay, so what is the intuition, right? Now let's build some intuition, right? And notice what is happening here. Okay. So here, each layer, if you talk about, right, is basically a Pascal triangle, right? If you know the Pascal triangle, this is a Pascal triangle where each number is formed by adding two numbers. If you take these two numbers, if it forms a new number, right, like 3, right, it means what? Adding these two number 1 and 2, similarly for the 2 and 3 and 3 and 4 and 4 and 5, we creating the new array row on, right? So each number is formed, each number you can say like 3, 5, 7 and 9. Each number is found by adding two numbers above, right? 1 and 2, like that. So in fact, the final triangle is taking a linear combination of the original numbers, and then we are forming like a triangle, we can say that we have seen, correct? So this is called linear combination of the original numbers with the binomial coefficient, right? If you know the binomial coefficient, right? So the oh, binomial coefficient, okay? So this is called the Pascal triangle here, right? But for the coding interview, we don't need to go that far. The simplest way is just simulate what the problem is describing here. Okay. So both perspective, give me 1 minute. So both perspective, let's think about the simulation method where we repeatedly compress the array, right? Or this is the first approach, you can say, means, or we can say math approach, math method, right? Where the formula is formula with, we can say formula with binomial coefficient with mod 10, right? Let's understand. Let's take about the example that we are talking about, the math approach, right? I'm not going to do this approach, we'll go by this approach itself, but I want to give you a little idea about the math approach, right? So let's suppose you are going with the approach called binomial coefficient method. If somebody want to do, for them I'm saying, okay? So this is not the method, this is we can say a formula, right? So let's suppose the final value equals what? It should be equal to, we know that it start at 0 and it will go to n minus 1, and if we want to take, let's suppose call I, we'll say n minus 1, right? Then we'll multiply with the nums at I, we can say that, and then we'll take the mod 10, right? Because each layer behaves like a Pascal triangle, right? So this will give you the final value using the binomial coefficient, right? So the concept is elegant here and could be faster than O of n square that we will use. If you can compute coefficient efficiently, then it is perfect. But cons here is it will take the modulus 10, right? And is not a prime number, so you can't use the standard modular inversion function here directly. So it will require the handling the mode of 2 and 5 like that. You have to apply again. So I will not recommend this, but for the practice wise, I'll suggest please go and try itself, right? Let's talk about the simulation approach. Okay, so how we are going to implement it. So very first, what we will do. So let's suppose we have given a method. Let's call it's a public int, and method is triangular sum. This is what we have given, and the argument is a given array, right? So here we'll create a for loop, right? And we'll say, okay, we want a window of elements, right? Okay, so we'll say, okay, take a length, right? And start from the last element, nums dot length, and the length should be greater than 1, and reduce the length minus each time. Okay, so once you do that, create another for loop and start I equal to 0, and I should be less than length length minus 1 and I plus plus. And we know what we need to do. So let's suppose each time I will update the value nums at I. Nums at I is nothing but, we'll say nums at I plus nums at I plus 1, sorry. And then we have to take the its mod 10, right? So this new value will be updated directly. You don't need to find here again. Once these are done, you just need to return the nums at 0. This is very easy, right? This is what we need to develop. Means we will take one array outside, outside loop we will take, start from the last, and we'll keep moving ahead, right? Means what we are trying to do, let's suppose we have given couple of elements we have given here. This is our array. So if this is your 0, 1, 2, 3, 4, so I'm saying you start from here, right? And we'll go until if length will come here till here, let's suppose. Okay, then the length should be what? It should be greater than 1. Okay, so I'm saying, okay, greater than 1. Start with the 4, greater than 1. So this is our things we will start. Then I'm saying this is our L length that start from what? 4 to 1, we can say that. Understand? Then we'll take a int I and we'll say, okay, I, you start from, let's suppose for the we'll start from what? 4. So no, but we will start from 0 itself. We'll say 0 to go to the length minus 1. Okay, so when we'll say length is equal to, let's suppose 4, so the I will start where? It will start from 0 and it will go to till where? Till 3, right? So we'll say, okay, start from 0, go till here. Means we are discarding one element. Again, when the length will come here, we will go start from here, we'll go till here, right? Similarly, when length come here too, we'll take only 2 elements. Like that, we will keep going ahead. When the length will come here, we'll go for only 2 elements. So this is what we are trying to achieve here. Okay, let's go to the console, then you will understand. So this is called Pascal Triangle. See how to implement it. So very first we'll start the length from nums.length, and length will greater than 1, length minus, and the loop will start from 0 to length minus 1, and each time we'll find the 2 elements and we'll add the sum and we'll get the new some elements. I hope you like this video, guys. If you need any help, please write in the comment section and I'll see you there. Bye bye.